This lecture is on properties of logarithms. We'll start off with these three properties. The log base a of product u times v is log base a of u plus log base a of v. That is, the log of a product is the sum of two logs. And likewise, the log of a quotient is the difference of two logs. Multiplication and division, sort of analogous with addition and subtraction. And finally, for exponents inside logs, you can put them in front as coefficients. And so what we'll be doing is sometimes going from left to right with these properties, and sometimes from right to left, depending upon what we're trying to accomplish. So a couple examples of using our log properties. We want to write ln 6 in terms of ln 2 and ln 3. So we realize that 6 is the same as 2 times 3. So ln 6 is ln 2 times 3, which then becomes ln 2 plus ln 3 by properties of logs. And now, of course, these properties of logs are all based upon properties of exponents. Natural log of 2 over 27, using 2's and 3's again and associated powers, I can write this quotient as a difference of two logs, ln 2 minus ln 27, and then realizing that 27 is 3 cubed, I have ln 2 minus ln 3 cubed, and finally ln 2 minus 3 ln 3. So now let's derive one of the log properties. I didn't do that here, but we will over here with our change of base derivation. Now the change of base formula, which I'll derive in a moment, is useful when you have a calculator that only does base e or base 10. Many new operating systems can do other bases, but not all can. And so what we do to find log base a of x in a new base, we'll use a base b, is first I'm going to set it equal to y, and we'll solve for y. Then I'm going to exponentiate both sides, a on each part. So a to the log base a of x is equal to x. That way I put it in exponential form, and now I can take a log base b of both sides, so log base b of the left. This will equal log base b of x. Now using the third property from before, I can take this exponent y and put it in front as a coefficient. So y log base b of a is log base b of x. And finally, solving for y, because that is in fact log base a of x, I can divide both sides by log base b of a. And here is our change of base formula. So the way I remember it is that the x is above the a here visually, so the x goes on top, a on the bottom. We've got our new base. Notice this is not the log of a quotient, it is the quotient of two logs. So that can be a little bit confusing sometimes with this second property, but they are quite different. So getting back into a couple more examples of this. Here we have log base 4 of 25, which is log 25 over log 4. Knowing that 4 squared is 16 and 4 cubed is 64, we expect log base 4 of 25 to be somewhere between 2 and 3, and of course it is. So it's a good idea to check your answers in some rough fashion. Log base 2 of 12 is log 12 over log 2. Of course we can use natural logs, ln 25 over ln 4, and ln 12 over ln 2. Now, using our properties, we can try to expand and condense logs. So that's the next thing we will look at. Here's expanding logarithmic expressions. So we have a log of a product, and we can split up this product of 5x cubed and y into 3 logs. Log base 4 of 5, log base 4 of x cubed, log base 4 of y. And then I can take this exponent, put it in front as a coefficient. In example 5b here, I've got the natural log of a quotient. So first I will take the square root, write it as a half power. Then I will separate this quotient into the difference of two logs, and then the half power can go in front as a coefficient. So that's expanding. We can also condense logarithmic expressions, put them back together. And so what we see here, for instance, is that I have 2 logs added, but I've got coefficients in front. So the first thing to do is to put the coefficients in as exponents. So I do that here. The half goes inside as an exponent, 3 goes in an exponent. X to the 1/2 is, of course, rad x. And now that I've got the sum of 2 logs, I can write it as the log of a product. So you can't combine them until you have the coefficients out of the way and inside the logs. Here I put the 2 inside as an exponent, and then I've got a difference of 2 logs, which I can write as a quotient. So the negative goes on the bottom, the positive one goes in the numerator on top. For this, the coefficient is out in front of everything, so first I'll combine these as a single log, and then I will put the 1/3 inside and take the cube root of everything. So a few more examples. This is again expansion using logarithmic properties. So it's a log of a product, so I can write it as the sum of these logs, and then of course these exponents can simply go in front as coefficients. Here I've got the log of a quotient, So that is the difference of two logs. I can't factor x squared plus 1, so I can't do anything more as far as expanding that. If it was x squared minus 1, of course I could do more factoring. Then finally I can take the half and put that in front. This is an example now of condensing with logs. I'll leave the 2 out front for the time being. The ln x here is positives, that's an enumerator. These are both negatives, so they both go in the denominator. Then I can multiply those together to get x squared minus 1, and now the 2 can go inside as an exponent, and I've got natural log of x over x squared minus 1 quantity squared. This is just a couple quick problems here. Log base 6 of the cube root of 6, of course the cube root of 6 is 6 to the 1/3. These cancel out, we get 1/3. And then finally, lest we forget, you can't take the log of a negative number, so don't try to do any change of basis with this. Log base 4 of negative 16 does not exist.